All right, Joshua, can you hear me?
Yep, I can hear.
Oh, sorry. Wait. Sorry, my headset. Okay, Joshua, can you hear me?
Yep, I can hear.
Wonderful. Okay. Today, Joshua, um, let me confirm first. Not a lot of worries on physics right now, yeah?
No, not really. I mean, like, uh, I'm okay with physics. Yeah.
Right. Um, Again, to repeat my prediction, most probably term 3, your teacher will discuss pressure. It is a very big risk if he does not discuss pressure. Okay, so that one. But you already done the questions, so you should be just making it more solid. Then he will do work energy power. There isn't much other than what I told you. So again, just exposure to questions. And your teacher is always good at giving you the questions. You're just waiting for it. Okay? After that comes another topic, which is also traditionally not very difficult. We just call it thermal topics, heat transfer. It's a more detailed version of what you are learning. Back then, you are learning conduction, convection is radiation. So you're going more detail to that one. Also, just waiting for a question. My prediction is term 3 will stop there. If not, then a little bit of light. That's all. Okay. So that's your term 3.
Okay.
Why am I telling you this? Because term 3 is therefore not very difficult. It has a different feel than term 1 and term 2. The hardest one is pressure, and you're already doing it. That means as you experience a general, more relaxed situation with physics, you just have to do the question, right? You can use the available time in 2 ways, to talk about chemistry more. That's one way, right? Also to talk about term 1 and term 2 physics. That is in general just for the sake of So we're doing it steadily and slowly. Okay. So that's physics. The outlook for chemistry term 3 is different. I keep telling you, the term 3 topics is really what you need to understand. Really what you need to understand, including the molar, which you have done. So acid-base solubility and qualitative analysis, and maybe one more, which we have not had time to talk about now. So term 3 chemistry must be considered to be, okay, I must understand. Right? Let's do it together, right? That's what I mean. Now, the unfortunate thing about term 3 chemistry is that people mistake it for a lot of memorization. I will propose that today we clear most of the memorization. This is very rare for me to do. I rarely do memorization with students, but this one, hopefully, after doing it for just one slot, right, you will feel ready and it is no longer a burden. Okay. There is a lot, to be fair, there is a lot, but the topic itself cannot be done properly just with memorization. It's a very common misunderstanding. Okay, so I'm just settling the memorization when we are in a relaxed state. I hope right now you are still quite relaxed, right? Okay, yeah. So that's what we're going to do. We're gonna. This is also my first time seeing your memorization. I want to see how good you are in memorization, or in some cases how bad. If it is bad, I mean there's a lot of ways to do it to make it better. If it is good, then let's, so to speak, get it out of the way, the memorization part. Okay. So this will be a bit different than the usual stuff. Let me share my screen first. Okay, right. So I did share with you the special Jamboard that other students use, Okay. Okay. So. I'm going to show you something. Right. So you look at my screen for a while. No need to look at the Jamboard for a while. Is this too small?
No, I can see it.
Right. So here is, for example, a memorization table. They won't give you in exam lah. Like you're supposed to just know this by heart, right? I'm not trying to get you to know this by heart. I'm trying to, first of all, make it feel that it is not a burden. And secondly, hopefully make it feel that you can use it. Okay. If I cannot show you how to use it, then I will definitely show you next week, something like that.
Okay.
So next week, I predict there won't be much problem with your physics. Like, I don't think so. Right? So chemistry, we can focus. Okay. So this is a test for guesses, meaning let's be clear, most of these gases are colorless and smellless also. Only ammonia has some sort of smell. Okay. So you cannot detect it by your sight and you cannot detect it by your smell, nor should you detect something by your smell.
Dangerous.
Yes. Smell means touching your nose already. Seeing might mean you are still far. You are not in contact. Very important, right? But most of them cannot see. So the identification consists of making them visible in some way. I hope that makes sense. Yeah.
Okay.
Now, they come in pairs. Some of them you might know already, right? So hydrogen gas pops, oxygen relights. What does this mean? It's very simple. Hydrogen explodes. That's what it means. The pop is a small explosion. Pop, it's an explosion, but very small. Oxygen relights, meaning oxygen is needed for burning. So if the fire goes down, you give it oxygen, it glows brighter. A very fancy way of basically doing barbecue lah. Barbecue, you fan ma?
Yeah.
Why do you fan the barbecue?
You get the oxygen, I guess.
And make the coal glow brighter. The coal go brighter, it will be hotter. When it is too hot, you don't fan the coal, right? Simple stuff lah. That's just oxygen. It's oxygen, right? So unlike your candle, you don't blow out coal. You make the coal glow brighter. A candle, you can blow it up. A coal cannot. Okay? Something like that. So, hey, not so difficult to memorize. Now, another pair would be this guy. Ammonia and chlorine. I know chlorine, it is said here to bleach damp litmus paper. But before that, he will turn a damp litmus paper from blue to red. This one will turn a damp litmus paper from red to blue lah. Because this is acidic when damp, and this is basic when damp. Both up.
Chlorine, blue to red.
Yeah. So
ammonia, red to blue. Okay.
Yeah. And there's an additional effect of chlorine, which is to bleach.
Bleaching. Yep.
Yeah. Which is to make the litmus paper no longer usable.
I think I tried this in lab before. So I think like
wonderful.
I put it in and then it was too long. So then I had to and then when I took it out, it was white.
Correct.
Yeah.
But that is not a failure, no? That is
it's part of the
So I'm happier if you've done this in lab. By right, these are all lab stuff. What by right, I mean, it is not nice to put it on text. It is just supposed to express what you're seeing or what you're doing. But maybe some things you haven't done, some things you won't do. I don't. So they make sure that you just know this stuff because for practical reasons in exam they don't. Right. So if you already understand, good for you. Memorization easier. Right. Now, carbon dioxide, I don't know. You should know by this one. This is a very popular one.
Yeah.
Sulfur dioxide is slightly harder because you probably haven't done this. And the wording very weird one. What is this? Acidified, potassium manganate. Why is it purple to colorless? Well, you memorize it. You memorize. Yeah. So that's your first task, Joshua. You memorize the easiest table first, which is this one. How you do it is just you give yourself some time to memorize. Then you close the Jamboard. You close the Jamboard or you don't look at it. You write on a piece of paper. and then you look at the Jamboard, make a correction with a different color pen. Okay, that is your first memorization for the day. Okay.
Okay.
Now, you should go into the Jamboard because I will be switching the screen. Okay.
Okay.
Page 3. Okay, Daniel, I can see you. Can you hear?
Yep.
Wonderful. Same Jamboard or different Jamboard?
I made a new one, added you.
Right. Okay, I'll go to the chemistry one. Okay. Yeah, okay, yes. Good.
Sorry, where am I supposed to? In the so I can write the thing on the paper, right? Another piece of paper.
Another place because it's faster, but you go and memorize first before you try to read.
Okay.
I'm not asking for perfection, okay? I'm just asking for familiarization, right? So don't spend like half an hour memorizing it. That's not the point, right? That's not the point, right? Maybe after 5 minutes, just do it. Okay, so for Daniel, I think I have your picture and I'll be drawing what you draw. Where is it? Oh, there you go. You just copy that. Okay, definitely agree with you. That looks like butanol. Oops, sorry. Okay, right. So to do this one, I believe the logic is just like last time. Okay, so you're gonna find something which is m over z. So let me clarify first, Daniel. The m over z, you know, yeah, the m will be the something and the z will be the something. What is the m and what is the z?
That is a good question.
Right. You yeah, we do it. We do that. But that's something normal that you already know in chemistry. For example, the Z is a very normal thing. What is the Z?
Relative mass.
Yeah.
What is M?
Wait, no. I think that's the proton number. Okay, I'm gonna make the thing bigger first while you just take a look lah.
Oh, Z is charge.
Hey, wait. Wait, what? Wait, now I'm confused. Wait. Okay. The M is the MR though, right? So correct, yeah? The M is the MR lah. Wait, let me confirm. Oh yeah, okay, oops, the charge, right? So the charge and the mass. So if there is no charge, then you cannot detect it, right? So mass means the MR, right? And the MR of who? So this will be your H. H. I'll write this out as my C. This should be my C1, no? My C2, my C3, my C4, just to make it easier. And then I'll have my H3 here, right? Okay, I'm sorry, it'll make it confusing. So making confusing. I just put it in small letters. C number 4, C number 3, C number 2, C number 1, and you have my double bond. I'm going to make it very clear that this C2 has 2 H's, and I'm going to make it very clear this C2 also has 2 H's. Right. Okay, so far so good. Daniel, are you seeing my screen? Better use my screen.
Yeah, I see your screen.
Did I get it correct? Yeah. Okay, I'm checking. Yeah, yeah. Okay, good. So I'm supposed to cut them almost as if randomly. Yeah, almost as if randomly. I'm supposed to cut them to random pieces, and I'm supposed to assign some charges to them. Okay, and then I'm supposed to now find a possible cut versus charge, right? That's what I'm trying to do. let me show you. I'm randomly cutting here, right? I'm randomly cutting here and then just focusing on this one. So I'm cutting a CH3 species and I am just finding it and I'm finding an MR for it. So would you kindly find an MR for this guy? The MR will be 12 plus 3. Am I correct? MR will be 17. Will this be okay so far?
Yeah.
Yeah. Now, and then the Z is simply the charge, right? So not sure what the charge is, but let me put it this way. The charge can be 1, the charge can be 2, the charge can be 3, and so on and so forth, right? 1, 2, 3. So if you want M over Z, I'm not going to get 29, no matter what the charge is. 17 divided by 1 or 2 or 3 is not going to give me 29. So I don't care about this species, right? This species is probably there, by the way. This species is probably here. You see that? Here. That should be your 17 over 1, probably.
But it's not.
It's not what they want. No? It's not what they want. They want 29. So I just go and cut stuff until I find 29. Really, that's what I'm going to do right now. Okay, so finding another species. Maybe I cut here, maybe lah. Maybe. So now I have CH3 and then with a C, H2 lah. And the MR here will be?
MR of what?
The cut. The random cut I did. I cut here and then I do that.
So you're asking for H5.
C2H5, yes.
29.
29, which is oh wow 29 M over Z lah. So by simple guessing, this is not even a confirm one, but by simple guessing, I'm guessing the M over Z21 will be the MR29 over a charge of 1. I have to give this guy a charge of 1 somehow positive or negative, but this is very likely the first guy we're looking for, very likely.
Just chopping it up.
Yeah, we are definitely chopping it up. That's how mass spectrometer goes. We chop things up.
Okay.
And for some reason, when we chop things up, some of them will have a charge. Not all, but some will. So you're going to assign a charge to it to account for it, because the one that does not have a charge will not be able to be measured. It's not that they don't exist. It's just that they're not measured. Okay. So this is my first guess for the first guy. Must be the first guy. First guy. It's too good to be true. First guy. Would you mind doing a random chop in order to find 43? You do it.
Maybe cut it between the
C1 and C2, I guess. Maybe, right?
Yeah, between C1 and C2.
Right. And then find out for yourself what that MR is. See whether there's a coincidence, I would say. Simple math at that point. Joshua, I would propose that you take a paper, don't look at your Jamboard, and just write down what you remember. Let's not be perfect. Okay?
Okay. I wrote down a few things, but I don't think it's like sent proper words.
No problem. No
so
problem.
I wrote down ammonia, damp, red litmus to blue.
Oh wait, don't tell me. Don't tell me.
Okay. All right. Okay.
You have written and you have stopped writing, right? You have, right?
Yeah, I have.
Take a different color, please. You need 2 colors. Take a different color. And then you go and
write down the right one.
Yeah, you just check with the Jamboard and correct the right one. So you have 2 colors and you just send it to me. Okay. Why are you sending it to me? Because I want to know how good you are in memorizing. This is important, at least for me.
Let me rewrite. I think my previous one was like quite ugly, so
No problem.
handwriting.
But,
Okay.
yeah. But don't be too perfect. You understand? That? Okay, that's not the goal here. Oh, a COH is also 29. We have an option here. Right? 12, 16, 20. Oh. Are you sure COH is 29, Daniel? Are you sure? You check again.
Yeah.
Check again, yeah?
Is it not 29?
I believe not.
Do tell.
CMR is AR, sorry, AR. CAR is
12,
good. Agree. OAR is
16.
so 20. Oh, 28. My goodness. No, that was me wrong. I was wrong. 29.
Okay.
Okay. Now you're getting CH2, and H. Okay, sorry, for this 31, how do you get the 30? Sorry, how do you chop this? Sorry, how are you chopping this? How are you chopping this?
Don't know.
The chop needs to be kind of like a simple chop. For example, you cannot chop twice and then combine the pieces. You can't. That's not what they're doing. If this is already in pieces, it will register in pieces. That means, for example, when I chop here, I think this is one piece and this is another piece. I don't go combine a piece from here and a piece from here because they won't combine. They will just register as different stuff. So this chop is, how do you chop?
CH2, CH2, CH.
So this must be 2, right? Must be this 2. But where does the H1 come from? Because here is C2H2 bold. I don't see a H1 here. I don't see a H1 here. Does that make sense? That means I don't think that's a possible chop.
All right, oh, we better chop then.
Yeah. So like a chop should be simple, right? Chop one place, you have 2 pieces. Chop one place, you have 2 pieces, right? Chop another place, you have 2 pieces, Like, for example, this 29 chop will give you this and another guy here. That would be, because a chop always give you 2 pieces, so to speak. Let's go.
So I can chop it like this and like this, 2 chops.
Yeah, but you cannot combine them. You chop them already, man.
Yeah, I'm not combining them. I'm just showing you where I'm chopping them.
Okay, sure.
Like that.
Sure. Can I suggest that you do a big piece chop, not a small piece chop? Because we're looking for 29 and then 43. 43 is very close. 43 is very, very close. And 72 is an even bigger piece. So we should be more like, we should be getting.
This is 43. This is 17.
One more time. A combination, this combination makes sense because it looks like this in a chop. This thing, I think what you're saying that is this thing. So it's actually a chop here and this thing is 43. I think you found the 43.
Yeah.
But this combination doesn't seem to make sense because you cannot get CH2 and H3. You cannot. What happened to the C in the middle? You can't get 17 that way, so to speak.
Wait, there's another C here.
If that makes sense. If not, how can there be a H3 here, right? Because butanol, C1, C2, C3, C4, so to speak, right?
So interesting.
And that will be our original 29, right? That will be original 29. Your 29 can be this guy, can be this guy, wonderful, wonderful stuff. You found your 43, which is I like a lot. We just have to find 72 lah.
Mine.
So this means that you're chopping. Oh, that means nothing is chopped. Wait, does that make sense? I think so. 48. Yeah, I think that makes a lot of sense. Yeah, I think that. So there's no chop lah. Yes.
Okay, great.
But then how do you get a? But again, how do you get a charge? Right? But there is a tick on 72. Oh wow. Okay. Wait, what? Let me check one more time. 48, 52, 56. You're right, it is 72.
Hello.
Yeah, no, I'm considering the charge. I'm considering the how do you get the charge for 72 one? Wait, I'm a bit confused.
Just add them together. 43 plus 29.
That's the whole thing. That means there is no
Yeah.
chop. If there is no
Exactly.
chop, how could they get a charge? You get the charge usually by the chop. By the process of chopping, you end up having a charge at both sides. There is no chop here.
Let me see the answer.
Oh, and how do you do that?
Yeah. The answer is the whole thing positively charged.
And how are you able to? Okay. So obviously that's beyond my knowledge lah. That is obviously beyond my knowledge lah, right? As far as I can tell, if you add a positive charge, you're supposed to add a H plus lah, and that's not happening here. Okay. Okay. For the 72 one, I give up. Okay. That works.
Okay, but I think the other ones didn't make sense.
The other one, sorry, makes sense or does not make sense?
Makes sense.
Yeah, I mean a chop will grant a charge positive, negative to both chops lah, because you're splitting the electron lah. Okay, that makes sense. Okay, I guess I owe you an explanation on the 72 one. Any other chemistry question?
Nah, that's about it.
All right. Okay, then your choice. Where do we go after this?
Revised physics, chapter 12 and chapter 7, like nuclear physics.
Sure. Okay. I understand, Joshua. So that's the easy one, yeah. Right. Joshua, if you look at page 3, the same page lah, you have the second table, which should feel new and slightly hard, right?
Okay.
So there are 6 lah. The ones that I cancel are not in the same.
Okay.
There's 6 here. So 1, 2. Now this is no longer a gas. These are negative ions lah, and ions. Okay. Same process, and write it down after you're comfortable, and then correct yourself. At most 10 minutes. Yeah. Okay. Familiarity. Familiarity is the key.
Okay.
Yeah. So since this will be a lot of memorization, I keep giving you stuff. When you are finally tired, you tell me, Joshua.
Yep.
Okay. So Daniel joining you in physics, and you want a discussion of chapter 12, right? Okay. So would you kindly send me this time? Let me share the screen. We'll discuss the slide from my screen sharing. Would that be okay?
Yeah, actually. So I send you a WhatsApp.
Yes, please. Waiting for it.
Sending over.
You're giving me a photo, right? And that's a question. Oh, sorry. I thought you want to talk about slides. Okay, questions are better. Okay, so on question 10, yeah, Daniel. Is this topic simply the radiation, right? Alpha particle dash radiation, or do you think we might need a formula from another topic?
Wait, sorry, I'm just.
Please do. Please. If you're sending, I just keep putting it first. Yeah, good. Let me do that. Get this done.
Electromagnetic power transmission, binding energy accent, structure of matter, yes, photoelectric effect. Photoelectric effect.
Which is yeah, we should try that. At least you should be able to do that without me reminding you lah. That's my hope lah. Right. Joshua, even though it's memorization, you can clarify things. Do you need to clarify anything?
I think I'm okay.
Forgot
yeah.
to answer this one.
Wait, what's the when they said liberated unheating, right? What does that mean?
Right, very simple. It's just that it will bubble up. No? Very fancy word. Lah. So when you heat up CO3 minus with value acids, you will see bubbling, and that bubbling will be CO2.
Oh, so just go out as gas and
something like that. So the bubble. Now, what does the bubble? What must you do with the bubble? Technically, you must test the bubble with your test for gases.
Okay.
So your carbonate test involves test for CO2. Your NO3, the nitrate test, involves test for ammonia, which is what you memorize just now. Yeah. Okay. Do you have something else? Yes, Daniel, you sent me, no, 4, you sent me 4, right? Okay.
Simple.
Okay, I think I put 4 pages already. So the first one, the question 9, right? Part A lah, for 4 marks. Only the alpha, beta, gamma, the radiation topic, or do we need also another formula from another chapter? That would be my clue.
Suvat.
Suvat, maybe not. Okay, but try again. Give you a clue. Alpha particle got charge or no charge?
What charge?
Okay, the charge will be what is the charge? Yeah, we need the charge, but we do. So what is an alpha particle? Yeah, what is an alpha particle? Then you know the charge.
It's an electron, right? Or is it a proton?
That's beta. Beta particles
So
are
it's a-
electron.
Alpha is a proton.
No, that's not true. However, it has positive charges. It has. So an alpha particle, later on they find out. You need to know this. So you need to memorize this. It is a helium, but with 2 plus. 2 plus helium. So if you know there's a helium 2 plus, you know that the proton number is 2. Okay, you know that this guy has no electron, so plus. And then you also know that he has a AR of 4. AR of 4, you might need it later on, suggesting. Okay, so alpha particle has 2 plus. A gold nucleus. What does a gold nucleus contain?
AG, right?
No, AU. Close to AG.
Oh, RM.
Yeah, close to AG. What does it contain?
I'm trying to find it. A 79196.
Right, so 79 protons and don't know how many neutrons, right? Something like that.
Yeah.
Giving you the clue. This needs to be the last clue. Hopefully you get it. So does a gold nucleus have a charge or not?
No.
What are you talking about, Daniel? You just said that gold nucleus contains 79 protons and don't know how many neutrons are. 40 neutrons, okay. So a gold nucleus have a charge or not?
Positive charge.
How many? Just to confirm.
79.
Yeah, would that make sense? A gold nucleus will have 79 plus charges.
Okay.
So reading the question, determine the distance of closest approach of a positive 2 charge towards a 79 plus charges. Ring any bell from other chapter?
Electric field.
Electric field will tell you that when a positive charge goes close to another positive charge, they will
repel.
All right. So is it making any sense? Like you may need that chapter. We may need that chapter. Any possible, the 4 siblings, right? Any possible, one of the 4 formula to apply?
I want to say F equals KQ1 Q2 for R squared.
There is that. So I'm going to write it down first because that's the most complete one, right? That's the most complete one. Right. So from the others, you can determine. So let's talk about this guy. So obviously, the alpha particle will be repelled by the gold nucleus. That's not obvious. Okay. However, you don't know the radius because that means the alpha particle can be far. This is your alpha, and your gold nucleus, which is a bunch of grapes, right? Bunch of grapes, 79, whatever, grapes. It can be far or it can be close. This one, the F will be smaller. This one, the F will be greater. So, hey, where's my distance? The question is not telling me. That's one. Secondly, he is asking for the distance. So that means where it's going in, and he cannot go in anymore, and afterwards he will go back. I hope that makes sense. Okay, so let's call this that distance, right? So this R. The problem with this formula is you need this R. That makes sense. You need this R. But they're asking you for the R, so you'll never get it from the question. The question is asking for you the R, if that makes some sense.
I can use I have an idea.
Yes, yes. You can use something because they give you something, right? They do.
Use EQ.
Joshua,
then-
understand. Okay.
So E is Q is plus.
You can, I think that's the +2 lah, I think. The
E
+2.
is 6 MV. MEV.
MEV. What is that? Sorry, what is that? ME6 MEV. Why is the field 6 MeV? I'm sorry. Why is the field 6 mega electron volt?
Isn't that E?
That's the kinetic energy.
Wait, so
That-
F is force.
Correct. F is force, definitely. That big E is not kinetic energy. That big
Oh, then
E
might as well
is the
use F.
electric field. That's the electric
We
field.
don't need to use this. Use the KE.
Nice, nice. Yes, yes. What you got?
equals
Yes.
half MV squared.
For you, Joshua, let me summarize the nitrate. The nitrate seems to be hard at first. It's very simple. Eh? For nitrate, you add 3 things. Add aluminium, add OH minus, add heat loss. That's how I would recommend you memorizing.
Aluminium, OH.
minus, and heat. Add 3 things. How come these 3 things? Don't know, but it will give you ammonia gas.
Aluminium, OH,
Minus and heat
and heat, and then ammonia gas.
will bubble up, which you can test with the gas test.
Okay.
Make sense? Huh? Sense? For the barium one, sulfate one, I guess you memorize this. You will see later why it will be easy lah. But for now, just memorize it. Okay, Ken? You okay with this? Huh?
Okay.
Okay. I'm not asking you to memorize it fully. No, yeah? No, good. No. Now go to the page 1. Go to page 1. Okay. You don't memorize everything. You just memorize 4. Eh? This is the hardest one because I'm not sure. Some people consider it the hardest. I don't know. Hopefully it's okay for you. 1. 2. 3. 4. Okay. Only 4. These are probably the hardest. Probably. Okay. Give it a try. Page 1. Yeah. Yes, nice, nice. Okay. Okay. You can find the V square. I agree with you, Daniel, but okay. I think you're on the right direction, yeah, but maybe I'll give you some hint, okay? Let's say here you have the KE, right? Here you have the KE, correct? So as it approaches the nucleus, right, it will slow down, correct? Does that make sense? It will slow down. Would that make some sense? You can look at my screen, okay? So when it slows down, it's losing kinetic energy. Tell me the kinetic energy becomes what? You cannot just lose energy, right? It must become something. No heat at all because this alpha is not conduction, no convection, and in this case, no radiation also. So I tell you that it's not becoming heat, definitely not. It's becoming something else, which is actually quite familiar. Because, giving you another hint, the nucleus is like a mountain. He is like approaching a mountain. When you approach a mountain, you go up the mountain. Imagine it that way lah. Okay, so you have a KE at the bottom of the mountain and you're approaching the mountain. You're losing your speed because you're gaining.
Height.
Even though there is no height here, he feels like he's climbing up the mountain. He feels like it. That's how positive approaching positive feels like. So he's gaining height, which means what kind of energy?
I don't know, man.
GPE?
You can't have GPE for proton.
You have one of the 4 siblings, you have, no, sorry, what am I talking about? Not GPE, EPE, sorry, electric potential energy. Sorry to confuse. Electric potential energy. you have electric potential energy.
What?
Yeah, I mean, I keep repeating this for you until you get it one day. Yeah, I keep repeating this for you. You find this to be new, it is not new lah. Right? Last time we talked about it. So here's where your Ke is maximum lah. In the alpha particle far away, approaching the proton filled nucleus, he will have Ke0 when it stops, right? When it stops. That's the closest distance lah. So the Ke has fully changed to electric potential energy, which is totally something that we can use here. And that is one of the formula that you have in that chapter. Okay, so this is your EPE max lah, which is going to be equal to your Ke max. Do you remember any formula for the electric potential energy?
G would be
something
Q over R squared A over R.
Over R, yes. Over R, yes. Yes. Over R. Okay, if you know the formula, I believe you have everything you need to apply it, I believe. Would you please write down the formula and apply it? Joshua, are you okay with this new table?
Struggling a bit more on this one.
Yep, definitely.
Copper, iron, and chromium is hard to memorize. I think the rest is
no. Wait. Don't do copper, iron. No. Just do the 1, 2, 3, 4. Just the 4.
Okay.
Just the 4. The 4 is,
okay.
But so happens the 4 seems to be the hardest one. You're right. The rest is easy. You're right.
I mean, like the rest is in my opinion harder though. Like why precipitate on?
Yeah, the 1, 2, 3, 4 is the hardest one. And I'm asking you only for the 1, 2, 3, 4. As in, I did write something, right? I did write this 1, this 2, this 3, this 4, right? I did. So those things only.
Okay.
That would be K. Yes. Okay. Right.
So we're trying to find R.
You're right. So you need the W, which you have the W, right? You do have the W, which is the Ke, wonderful, which is something, half mv squared, wonderful, which is what you wrote just now. This needs to time 1.6 times 10 to the power minus 19. If you don't understand, please tell me. Coulomb.
Why?
Yeah, because no, that's not EV. That happens to be the same exact number. You're right, but remember the charge is in Coulomb lah. So plus 2 charges is 2 this amount of Coulomb. 79 is 79 times this amount of Coulomb. That means this is a charge of one proton or one neutron, one electron, sorry. This is called the elementary charge. It's 2 times this and 79 times this. If this doesn't make any sense, please tell me again.
Right. M is what?
The mass of the electron, which is given.
Try do it in
You need to do it in SI. I think that's the easiest way.
which one? Kilograms.
SI.
Hello. Hello. Stuff. Exercising. Exercising. Okay. The Pilates.
We later learned that all the
Testing. Can you hear me, Josh?
Yep, I can hear you.
All right. So good job on the 3 tables, right? There was 3 already. Then I'm asking you to refresh the acid base list lah. Do you still remember them? It's not in this Jamboard. It's on the one we talked about.
Aiden, right?
Yep. If you cannot find it, you tell me.
Yep, I can find it. I found it.
Oh, okay, cool. So that one, and just memorize. Also not supposed to be very complicated.
Mm.
Okay, Daniel, can you hear me? Are you back? Yeah.
the acidic oxides and basic oxides as well?
Yeah, because they are part of the acid and base list,
Okay.
and they will be used lah. They will be
Okay.
used. So Daniel, to confirm, are you back? Joshua, are you okay so far?
Yeah, I'm listing down the things now.
Right. Well, what you're saying is that even with these four big groups, right? You don't feel burdened.
Oh, what do you mean?
We are measuring, like we memorize the gas one, right? Then the negative ion, then the positive ion, and then now you're refreshing the acid and base. Those are the four big groups, lah, right? You don't feel burden at all at this point.
I mean, like, once in a while I just have to review it back, but I don't think it's like that much of a burden.
Understood?
Considering like the cat ion's not actually that much as well.
Okay.
The cat ion's quite, yeah.
Understood. Yeah. Okay. Good. Good news. Good news. All right.
Wait, for the base, right?
Yeah.
It's only metallic, metal and
Metal oxide, metal hydroxide, basically.
do I have to list? I just write down metal oxide
Yeah.
and
Yeah, because every metal hydroxide is base, every metal oxide is base except the amphoteric, right? You know the exceptions, lah. Right? And then every metal is, base, so that's it, lah. That's it, lah. And don't forget one of the shy, there's one particularly shy hydroxide called ammonium hydroxide, which is not metal hydroxide, still hydroxide, look, the hydroxide. So that's the exception, no? Right. Again, you should have the impression that the base lists are much easier by right lah. Right?
Yeah.
Daniel, just to check, are you back?
Sorry, can I grab a cup of water?
Yes, please.
Thank you.
Hello.
Yes, you're back. I wrote something, yeah. I wrote something, yes. Daniel. Right. I'm just writing the other page first. Right. Please tell me, please read and tell me. Right. Okay. Okay, thanks for waiting.
So you calculate the mass
The
of
mass.
21 neutrons and 19 protons.
You're talking about the previous next
Part
page.
A.
Right? Yeah,
Part
yeah,
A, part A.
21, 20, yeah, 21, 19, because 40, right?
Yeah.
You gotta go to the double booklet and then you get used to it. Get used to it.
How does that help with binding energy per nucleon?
All right, so I guess I should have written it down in Let me put that one on top of here, and that will be the explanation. Should put an emphasis here. Oh. Now, if it doesn't make sense, please tell me. This is part of the physics. This is not only for this question. That means it's good to understand. Are you okay, Daniel?
Yeah. Okay.
The calculation, right? A little bit tedious, but for 4 marks, please get used to it. They like this, they like this. It's almost standard. Joshua, tell me if you are back.
Yeah, I'm good. I think I sent you, right? The
Wait, what? Okay. I have not.
Oh, wait, let me check. Sorry. Let me check. Oh, no. Hold on, give me a minute.
Okay. All right, so let me see. I'm saying yes. Good. The shy guy is a H2CO3 and then H4OH.
Yeah, sorry, I don't think my picture loaded in time, and then I closed the phone.
Right. So I believe you should memorize the exceptions for the acidic oxide. The exceptions for acidic oxide is CO, H2O, and NO. Those are the neutral oxides. So
Okay.
because most non-metal acids, non-metal oxides are acidic, except most metal oxides are basic, except zinc, aluminium, and lead. So memorize the exception.
Okay.
Okay. And with that, it's almost complete lah. Okay, so I will show you the last big group. The last big group in Jamboard page 4. We have 10 minutes. Right? Are you there? Please tell me. Okay, good, Daniel. Good. Yeah. Now, Daniel, don't forget it's per nucleon. So just this divided by 40. Okay, so Joshua, it's not all in page 4, okay? It's not all in page 4. So let me clarify what page 4 means. This looks a bit different than usual. So when a positive ion meets a negative ion, right? A positive ion meets a negative ion. There are three possible happening. First of all, they are soluble. Soluble means they fully separate in water. The separation is what they mean. They can also decide to hold hand together very tightly in water, meaning they are insoluble. They form precipitate. Can you can so far?
Yeah, okay.
The slightly soluble is the one that, oh yeah, you have a very little soluble part, but the rest is not. Let's pretend that that doesn't exist for now. Okay, now, the complicated thing to memorize is when you have so many variations and your syllabus seems to take out the difficult one to memorize. So I cancel F minus, meaning you don't have to memorize F minus. Understand?
Okay.
You don't have to memorize that. You
Hydroxide.
don't have to memorize chloride. Hydroxide, yes, hydroxide. Sulfide, no
yeah.
need. Right, so carbonate, yes, nitrate. Phosphate also no need. So if there is ever a complication, it looks like the hydroxide until you realize that most things are not lah. It's like most things are insoluble except for this guy. Okay, so let me cancel the one that you don't need. You don't need magnesium. You don't need. So you don't need, to be fair, you don't need iron 2, iron 3. Okay, let's make your life easier. Copper, do you need? No, no need. Okay, something like that. Now, I'll give you an advice, Joshua. The key is to memorize the exceptions. Nitrate is all soluble, finish, done, correct? No matter who nitrate pairs, it will always be soluble. Now chloride. Chloride is mostly soluble. That's what you want, except these two. Just
Silver
memorize the
and
exception. Yeah, just memorize the exception. Very easy one.
Okay.
And turns out that the exceptions are repeat offenders one. Look at that. They are really repeat offenders one. It's not very random if you want to say. Am I making any sense?
Mm-hmm.
The offenders are usually offenders.
Yeah.
Now, this is your last challenge, but around 3:30, 3:40, just stop. Okay? Okay, Daniel. Right. So, Daniel, for the 4 marks, okay, yeah? That one's okay, yeah? Daniel, are you okay?
Mm-hmm.
The part B, are you okay?
Yeah.
Right. So the more energy release, any idea why, who does it belong to lah? It may belong to the argon, but it may also belong to.
Okay.
I'm sorry, you're saying belong to?
Okay.
The K. No. The K releases less. So he's saying that when K becomes AR, right? When K40 becomes AR40, AR40 releases a bit more juice. Did that make sense? Because AR40 is even thinner than K40. So therefore, the binding energy is more in AR40. That's what binding energy more means. You are thinner. AR40 is thinner than K40, losing more mass lah, thinner. So that means you can squeeze out a bit more juice when you change from KR40 to AR40. Making any sense so far?
Yeah.
That juice, you can say, yeah, lah, that juice belongs to AR40, lah. Why so complicated? Or you can look at the reaction and say, oh, something else is flying out of AR40. That something else is, in this case, beta plus, lah, whatever beta plus is. This beta plus is the guy carrying the extra juice. Putting it another way, how can something fly away if he is not given juice lah? The juice is, well, there you go lah. That's where the extra juice belongs to or is carried by the beta plus kinetic energy.
Okay.
Okay, yeah. Finally, photoelectric effect. Would you kindly revise your photoelectric effect understanding? I would really hope that you can revise it quite fully lah. Right? I will help you, but please revise it by yourself first. I will help you along the way. Don't answer the question first lah, is what I'm trying to say.
Okay. So just right there.
Please do. That way I can help you maybe if you miss something. Right? What you understand. Don't give fancy words, okay? What you understand. No fancy words, yeah? You want to answer the question? Never mind. Right. So go ahead and answer the question. Joshua, are you okay so far?
Still slightly stuck on the hydroxide below.
Oh,
but
yeah,
like,
fair.
mm,
And hydroxide turns out to be important, so I guess.
sulfate is also annoying. So,
Mhm.
yeah.
This isn't really answering the question.
I like the word. Though. The wording is correct. I like the wording is correct, but if the understanding is there, the word will be natural lah. Your wording is okay, definitely okay so far lah, if that's your question. The wording are getting even better. The existence of this threshold frequency. Okay. So far, the wordings are making sense, I suppose. So far, yeah. From the metals up, okay. I mean, not so bad. Yeah, not so bad. Yeah, bad.
I don't know how it's shown. That's as far as I can go.
Okay, then I suppose I'll try to refresh. At this point, I am expecting you to recall the whatever explanations are back then that we discussed. Yeah. So if you want to draw the threshold frequency, could you draw it to illustrate what it is like? So never mind the English first, maybe the drawing first. how would it appear to you?
Minimal frequency.
Yeah. Whatever you think is relevant, please draw, because it feels that you know something, right? It feels like it. That's the electron flying out. Totally agree with that. Yep. That is a light, which is wonderful. Striking the surface, wonderful. That will be the metal, again, very wonderful. There is this stuff, right? Okay, yep, okay, right.
Yeah, then you combine these two.
Okay, which two? Nice. These two will be the total of the.
And this happens in here.
Okay. Right. So yeah.
So it's like 1, 2, and 3.
All right. And the who is equal to who and who, just to confirm that.
So what?
Between this 1, 2, 3, who is equal to who, just to confirm.
The threshold frequency.
No. Never mind the threshold frequency. Never mind that stuff. We are drawing is wonderful. 1, 2, 3. Who is equal to who? 1, 2, 3.
What are you asking?
Your 1, 2, 3. Your light, and this one. Who is equal to who in this 1, 2, 3? What's their relationship?
You mean in terms of energy?
Yes.
Like,
yes, always in terms of energy. Yes, very good.
1 is equal to 2 plus 3.
Wonderful. Now let's specify a few things. This is wonderful. Right? Now 1, the energy of 1 is, what is the formula to refresh?
Energy of 1.
Yeah, energy of light is, there's a simple formula. You don't need to memorize.
What is it?
So, Joshua, are you okay, you think?
E equals.
I don't think I can memorize all of them.
Wonderful. Write down, correct it, and
I don't know. I don't think I can write
oh,
down.
right. Okay. This is already 1 of our memorization, right? So you can stop here right now, but try to memorize that last one before we meet again next Wednesday.
Okay.
Now,
That's
the weird,
some homework then. But
yeah. Now, the weird thing is this: I forbid you to revise the other one. That means,
rest.
rest. I forbid you to revise, but on the next Wednesday, the start is that you will write down everything without revision. I specifically request that you will write it down without revision.
Okay.
Okay, but the last one you should because the last one happened, right? Okay, that's all.
Okay.
This is very good already. Okay.
Okay.
I'll see you
next week.
All right. Bye-bye.
Thank you. Bye-bye.
Wonderful, Daniel. So this is 1, right? This will be 1. Let me confirm the energy of electron first. The energy of the electron is what? So for number 3, yeah. The form of the energy possessed by the electron.
Yeah.
That would be?
H is Planck's constant.
H is Planck constant, and F is simply the frequency of the light. Yes, that will be number 1. Totally agree. Right. And the reason is you want to convert the frequency into energy. You want to talk in terms of energy, not in terms of frequency. Now, let's just complete our understanding here. The energy in part 3 is in what form?
Energy in what form?
Yeah, the electron possess energy in what form? Chemical energy, potential energy. I mean, cannot be light energy. I don't know, electrical energy, kinetic energy. Maybe not heat energy lah. So let's say it's not heat energy.
I don't know, man. Chemical?
Chemical, probably not, but just because there is no reaction here. Maybe if you look at part B, because sometimes they even let it out for you. Look at part B or what?
Part B.
Part B, yes, part B of the question. Okay, part B of the question. They even kind of like, yeah, part B, yes. The
Kinetic
type of
energy of the
yes,
emitted
kinetic energy.
electrons.
Yes, it's Ke lah. It's always going to be Ke, by the way lah. So, just to narrow our Ke lah. Okay. So now, back to part 1 first. Let's just settle part 1 first. Your understanding of the photoelectric is probably already enough for the calculation part, right? Okay, so for part 1, can you accept this? Whatever this threshold frequency means, it means something like this lah. It means that either 1 is equal to 2. That means currently the tree is 0 lah. 0. Currently the tree is 0. So 1 is kind of low lah, basically. 1 is low, such that nothing is left over for 3. Just 1 equals to 2. Or 1 is less than 2. So again, obviously, nothing is going to come up again. The tree is obviously 0 also. Okay. The threshold frequency would be this guy, though, because 1 can be equal, 1 can be smaller, or 1 can be bigger than 2. When it is bigger than 2, you're over that threshold frequency. Okay. This threshold frequency is determined by these two lah, right? Determined by these two. I have to overcome this thing. Okay. Am I making any sense so far?
Okay.
So the existence of this threshold frequency is shown by us explaining this law. It's shown by us explaining this guy. If you explain that, well, voila lah, that will be your form.
Voila.
Voila. Voila.
Voila, voila. Okay.
Voila.
Part two. Let's go. Right, it's different for different metals because different metals have
yes.
different
Yes.
resonance.
No. You
resonance.
already have the word here. You have the word here. You already have the word here. You have the word.
Different metals have different ionization levels.
And energy, or different, you want to say level, different energy levels.
Okay.
Different energy levels or different ionization energy. Yeah. When you want to explain the existence of levels, you refer to your chemistry, the existence of orbitals for the electrons. Basically, that's your answer for part 1. Yeah.
Okay.
For part
Determine
B,
the frequency of this incident. What?
Okay. You read this question first.
Maximum KE is 2.8. Oh, we must add them together.
Let me clarify. Why are you adding them together? Why?
Because it's part 1. It's part 3 and 2.
Oh, wonderful. I like it.
This Planck's constant. Six, 3 times.
It's already in Joule. Yes, wonderful. It's already in Joule. So we are kind of, that makes it easier. Good.
Minus 30. Oh no. Math. Nine point 6 times 10 to the power 14. Classical wave theory.
Okay, right. Frequency, just to confirm, the unit is?
Uh,
The unit will be?
Hertz.
Wonderful, right, wonderful, right. Okay. I don't know, it looks, wait, it looks, no, it doesn't look right. It doesn't, actually, it does not look right. It looks a bit, oh wait, what's going on? Let me check on. Yeah, what?
Huh?
Wait, sorry. How come the power 14 looks? Wait, sorry. Am I imagining? No, it doesn't look right. Doesn't look right. Yeah. Wait. Oh no. I'm sorry. I'm confusing myself. It looks right. Yeah, sorry. Wonderful. Okay. So for part C, I'm not sure I want to explain the classical wave theory, but I'll tell you a little bit about the answer and a little bit why it makes sense. Okay. The classical wave theory does not have this guy. Does not have this guy. This guy represents a certain thing. Yeah? This guy represents the fact that something like this. Okay. I'm
Which
sorry.
guy? I cannot see.
The energy level. Refer to the screen sharing for right. Screen sharing. Okay. This guy that you draw this guy. Okay. The energy levels of the orbital right. So I'm going to talk about them as if they are meters. Just make it easy. Let's say this is 2 meters. Let's say this is 1 meter. And let's say this is half a meter, right? So good?
Yep.
The classical wave theory, you don't even, it's not that you don't even study it, but they don't even bother to explain to you what is it. What it is something simpler than what we learned. That because the classical wave theory, whatever that is the one that is that comes before what we're learning back then. So back then they assume a certain things. Now we think this is a slightly better version of reality with all these levels. So classical wave theory did not think that there are such things as orbitals. Did not think that there are such things that electron jumping around. Did not think that electron, if he has energy to jump and he doesn't get to go to the second level, that means you only have 1 meter here. Let's say you have 1 meter here. He basically just to our view, it is as if he doesn't jump at all. He will only jump if he has exactly 2 meters going to him. If it is not 2 meters, he wouldn't jump. At least that is how it appears to us. All these details, right? Classical wave theory does not assume that all of this exists. Okay, then, so what is he unable to explain? So to him, classical wave theory looks like this here, and I guess okay, I know what to do. Right. Classical wave theory basically sees it not as a level, but as more like a solid, more like a, what do you call this? A smooth mountain, no? Meaning to say, this guy can keep collecting electrons along the way, and then he will keep climbing until he get up. He can collect more than one electron. So I have a, low energy electron. I go and eat the electron. I go up by a little bit. I eat another electron. I go up a bit. I eat another electron. Go up a bit, until he finally gets up the mountain. That is how we climb mountain, I suppose lah. We do have to bring enough food, or we do have to know how to find our own food. That is what you have to do when you go to NS lah, right? That is not the case with what we see from the electron. The electron say to you, either you give me enough or I just don't go. So meaning to say, if you, this is total of 3.5 meters lah. If you don't give me 3.5 meters worth of energy, if you just give me 3 meters, I am so sorry, it tells you. I cannot take your 3 meters and then take another 3 meters. I cannot take a 3 meter worth of energy and another 3 meter of energy. I just won't budge. I will keep doing that in short. I will not be able to eat a photon, and eat another photon to fly out. He can only eat one. So either it is enough or just never mind. If you give him 3.4, nothing is going to happen. In the classical wave theory, people are very confused. What's wrong with giving you a low energy photon? Just keep eating the photon until you go up lah. Now, in reality, that never happens lah. In reality, the electron doesn't respond this way. Back then, they're very confused lah. And then, whatever lah, the new theory comes in and turns out this one is the one more suitable for reality. I'm telling you a bit of history. That is what we're going to use to answer this question lah. Okay, so I'm going to say something based on that, okay? The classical wave theory predicts that an electron will be able to absorb more than one photon in order to, well, exit the metal surface. That is not true at all. What is true is that if you give low energy photon to the metal, no electron will exit at all. The classical wave theory predicts that that can be done, and in reality, it cannot be done. Yeah, your one. I don't think we should put too much effort to that, right?
Okay. Is that all the questions already?
I think so. Let me check one more. Yeah, I think so. You sent me 4 pages.
Okay. Shall we end now, or keep on going?
10 more minutes. Do something more. I don't know, vector lah, anything.
Okay. Let's see.
Vector. I like vector.
Vector for math.
Yeah, I think we haven't finished. Maybe you wanna, let's take a look at your math Jamboard, right? In the end, math will take most of our time. In the end, that's how math is, right? So if we have time, let's give it to math. Okay. Yeah, this thing. Kindly remember what happened in part 1. Kindly remember. Let me refresh you if you don't understand something. This thing lah. What is this thing lah? Do you remember what
Yeah.
we're trying to do here? Okay, according to your words, what's happening here?
I'm converting them all to the same form. Find the normal.
Normal, yes. We want the normal,
Yeah.
right? Because we want the normal.
And
Now,
then use the equation.
which is one? Because we haven't written it out. I think you already got it, right? I think you already.
Cosine theta. No, we talked about it. Sine theta equals.
We can do the sine theta one. We can. No, it's cosine theta. Sorry, if you're referring to this one, it'll be cosine theta. It'll be the cosine theta.
This is line and plane. What? Line and plane is sine theta.
So that I don't contradict yeah. Because in vector, the same thing can be presented. Let me just see your PDF. So
you can do cosine theta, but then you have to do 90 minus.
You are absolutely
minus
correct.
90.
No, correct. No, you're absolutely correct. You're shortcutting it. Okay, I won't disagree with your book. Okay, so that will be part one. Okay, that will be 4 marks.
Mm-hmm.
All right. So now part 2, another 4 marks, right? So find the coordinates of the point at which L intersects P. So basically find this guy, right? Find this guy. We'll call this guy something. I'll call it, I don't know, I'll call it I'll call it F line. I'll call it. Any idea how to do this? Surprisingly, it's not difficult at all. This is one of the nicest mark to get. After so many tedious way, this is, I think, one of the easiest one. 4 marks. Okay, now you see what I'm doing. Please try to understand it so that you remember. It's not very good to memorize. There are too many things to memorize.
You can sub in the L into the P.
You are absolutely correct. How do we do that? Now, how exactly do we do that? If you know how to, I'm very happy for them.
1 minus 2.
Okay, nice. Yes. Okay, you do that. Yes. Very nice. You do that.
Then you sub this.
And where do you sub it into? Yes. Nice. Very good. Yes. Very good. And then you have one equation with an unknown. You find the lambda, correct? You find the lambda. What do you do with the lambda? Is that the end?
Yes.
No, that's not a coordinate, by the way. But a lambda is very good. A lambda is very good. Into the?
Sub it back.
Sub it back into the? Where? I mean, you can just try to solve it, but you shouldn't stop at lambda, yeah? You shouldn't, that's 2 marks, though.
That's 1.
Wonderful. Again, lambda is not a coordinate, obviously, right? What do you do? What do you do with lambda? Lambda belongs to the line, right? In that sense, right? Lambda does not belong to the plane. Lambda belongs to the line. I'll phrase it somewhere. I hope that makes sense. When you give the line a lambda, that means when you determine the lambda for him, right? You collapse the line into a point. No? When you define a lambda for the line no longer exists as a line. It now exists as a point on the line, of course. You are defining the lambda as 1. You put it into the line back, the line will give you a point. Does that make any sense?
Yeah, it does.
Give it a try, and that will be finally an easy format, right? Finally, we deserve something. We deserve something easy after all.
Yay!
You wrote something? Is that okay? You wrote something already? Is it done? We have time for part 3. We have. Once you're done.
Part 3 is just for a perpendicular.
Which you misplane at point N now. I think you could do it back then with a line, right? Can you do it with a plane? Can you do it?
Yeah.
You sure? I mean, wonderful. 5 marks, not very difficult also. Not very difficult. Okay, wonderful. Now, part 6. Part 6 will definitely not be difficult if you can use either part 1, part 2, or part 3. Either one.
For
It's not a coincidence at all that this point exists in the line, It is totally not a coincidence. Do you see that?
yeah.
I tell you, part 4, you will need 2 and 3 at the very least. If you know that, so easy, 6 marks. So very easy. Can you see the wind? Give you a few minutes. If you could, I love it. I love it.
You just think.
Please do, and erase, erase whatever you want. Please do, whatever.
Then just solve for O.
O N is O. Which P are you talking about?
P is the point on the line. Oh, Fi. In this
The
case.
one 0. I'm not sure I follow what you're doing. I might be, maybe I'm just not thinking. I mean, but if you're confident, you can give it a try lah. You can give it a try first. Maybe you see something I don't see. That's definitely possible in vector. That's just possible. Give it a try lah. Give it a try. Since at least you know what you want to try, right? At least, right? If cannot, please tell me. Yeah, please tell me. Okay. That being said, this is the first time we meet so many times in a week lah. So many times. I hope you're not sick with your subjects or with tuition. Please tell me, remind me again what's going to happen next week in terms of school and exam. Remind me again so that I can adapt to you lah if needed lah.
Next week is exams.
Next week will be exams lah. So when will be the exams? We might need to, we might want to reschedule, right?
It's all in our chat.
Yes. So the question is, do we need to change the tuition a little bit lah, right? Okay, I'm just finding it. Oh, there you go. Wonderful. Okay, so Monday business. So you won't be worrying about. Okay. So for example, here's a question. Is it actually a good idea to have tuition on Sunday when you're supposed to worry about business management and Langlit on Tuesday? It's actually a good idea.
Probably not.
All right. To clarify, are you having normal school or after exam you come back?
After exam come back.
That means you have more flexibility with your tuition time lah, correct?
Yep.
Okay. Now here's the thing. You might you don't need tuition before chemistry, right? You don't, right? You don't really need that, right?
I don't mind.
So here's the thing lah. For chemistry,
can keep Tuesday night lah.
Tuesday night.
Keep Tuesday.
No, wait. Night is probably fine. Yeah. Okay. So the normal Tuesday night, right? The normal Tuesday night. Right?
Then just change Sunday to another day lah.
Wonderful. Which can be Thursday, can be Friday, can be just Thursday lah. I guess lah. Yeah. I guess that will be Thursday lah. Does it make sense to have tuition on Thursday? Think about it for a while.
Yeah. No, sure.
Okay, Thursday. And then the Sunday will already make sense, lah, right?
Yeah.
So final question is the next Tuesday does not make sense, ma?
Yeah.
So when do you want to change the next Tuesday to?
You make it Monday.
Okay, make it Monday, but can the Monday, I'll send you the timing later, lah. Yeah, I have to do some adjustment.
Monday morning.
Monday morning, is it possible? Maybe. Is that actually a good idea, Monday morning? Are you sure? Because Sunday night, no? Sunday night, Monday morning, does that make sense?
I already have like a tuition 5:30 to 7:30 on Monday.
Let's not do it at the night. Okay, let me send you some possibilities. So next Sunday, nope, change to Thursday, right? Next Tuesday,
Thursday what
change
time?
to Monday. Perhaps at night should be better, right? I'll send you the time, then we can talk about the details. Will that be okay?
Mm-hmm.
All right. I'll send you after we log off. Okay. Good job so far, Daniel. I will see you next Tuesday then.